All right, today we're going to have a video instruction going through the odd problems of your homework so that you can use this as best you can. Some of you may just fast forward and use this as an answer key. Others of you may need to go step by step. I'm going to start with number 1. I'm going to zoom in a little bit. And when I look at number 1, what I notice is I've got two operations. I have to subtract and I have to multiply. And with PEMDAS, what I know is that I have to multiply first. So I am going to make a bracket around 8 times 5. And I know 8 times 5, I can use my multiplication table and see that that's 40. Okay, so I'm going to switch back to black ink to show that the only thing I've done is consolidate 8 times 5 into 40. Now I've got to do 23 take away 40. 23 minus 40. Some of you may already have a strategy that works for you. The strategy that I've been using is one that we're going to use when we start solving equations. And that is to say that I've got 23 positives, which I do in green. And my instructions are that I'm supposed to take away 40 positives. I don't have enough positives here to take away 40. What I'm going to have to do is bring in enough positives that I can follow the directions I've been given and take away 40. I can take away 23, but if I want to take away 40, I'm going to have to add in another 17. But the rule is when I bring anything into a problem, I have to bring it in as 0. So I'm going to bring in negative 17 as well. This is called a zero pair. These two things together, positive 17 and negative 17, are called a zero pair. I can bring in or take away anything with a value of 0 into a math problem. So now if I go back to my original, this says I'm starting with 23, which I am, and I'm supposed to take away 40 positives. So I'm going to do that. I'm going to take away 40 positives, and what I'm left with is my answer. And in this case, I'm left with negative 17. So my final answer to this problem is negative 17. Number 3 introduces something new to the game, and that is exponents. So when I look at exponents, I know that that means I'm going to multiply the larger number, the base, that many times by itself. So in PEMDAS, the E in PEMDAS stands for exponents. That means that I'm going to have to address these two exponents first. I'm actually going to start over here at 3 to the power of 2. 3 to the power of 2 is the same thing as 3 times 3. I multiply the base 3 times itself 2 times. 3 times 3 equals 9. So underneath this, I'm going to put 9. Now the sign that came before it, I accidentally put in my bracket. That's a multiplication sign, and I'm going to bring that down so that I don't forget. Whatever comes next, I'm going to multiply by 9. So the next exponent that I need to look at is this 7 to the power of 2. Now you're going to run into a couple different cases with a negative number before an exponent, and each case is a little bit different. What I'm going to tell you about this one is, without any parentheses and without any substitution of letters, we're going to take 7 times 7, or 7 to the power of 2, and whatever our answer is, we're going to make it negative. That's what this type of symbol tells us. So if that's the case, that means that 7 times 7 is 49, but this negative means my answer should actually be negative 49. So I've dealt with the exponents, the two things that come first. I need to carry down every other part of my problem and see what to do next. So the next thing I notice is that there is an invisible multiplication sign in between a number and a set of parentheses. Okay, so what I have over here is two sets of multiplication, and we talked about being able to multiply from left to right. Okay, multiplication has the same level of importance, so we'll just kind of do this multiplication left to right. So first, I've got 2 times 7, which I know is 14. And then after that, I have to take that 14 and multiply it by 9. So using my multiplication table, I see that 14 times 9 is 126. Okay, so we're getting into some big numbers, but everything is still so far in my multiplication table. So bringing down all the other unused pieces so far, I want to make sure that I capture this minus that was here right before my work. So I have to get that minus in here. Now I've got negative 49 minus 6 minus 126. Okay, so this is going to turn into quite a big number. When we subtract all in a row, we usually just take the first two numbers, right, and do that subtraction, and then we'll subtract the next one. If you have a strategy to subtract, that is just fine. My strategy looks like this. I'm going to go over here and do my work. I have 49 negatives, right? And the directions here say take away 6 positives from that. If I look at what I don't have 6 positives to take away. So I'm going to bring those in to my starting place, but I'm not allowed to bring in positives alone. I can only bring in a 0 pair, or something that together equals 0. So as I bring in positive 6, I will also bring in its opposite, negative 6. Okay? And now when I go back to my problem, it says start with negative 49 and then take away 6 positives. So I'm going to take away those 6 positives. What I have left, right, is adding up my negative 49 and my negative 6 to be negative 55. Okay? Together I have 55 negatives. So I'm going to label this negative 55. The last thing I have to do then is subtract 126. And so I've got the same situation going on with this subtraction problem. I'm going to move my paper up a little bit so I have some space. I am starting with 55 negatives, which I always do in red, okay, and in a circle. And I'm being instructed to take away 126 positives, which I don't have any positives. So I'm going to bring in 126 positives so that I can take them away and follow orders. However, I can only bring in a 0 pair, so I also have to bring in the opposite. To bring in negative 126 at the same time. When I do that, I can subtract my 126 positives, and I'm left with all of these negatives that I have to add up. Now for this one, because I have to add all my negatives together, and it's quite big numbers I'm dealing with, I am going to add them this way. I'm going to do 6 plus 5 is 11, 3 plus 5 is 8. I have 181 negatives, okay? So my answer is actually negative 181. Number 5 is the most challenging we've had so far because there's so many pieces to it. But if we take it one step at a time, it shouldn't be too difficult. So we're going to begin, as we look at this, with parentheses. And I want to point out that the P in parentheses for PEMDAS is talking about this right here. There are parentheses over here, but these parentheses are one of those pretend multiplication, right? Or I should say invisible multiplication. So if you want to, you can go take a different color or something. There is an invisible multiplication dot between a number and parentheses. That is different than this set, which has something inside to do. We've actually got, within our parentheses, we've got subtraction, but before we do that, we have the E of PEMDAS, exponents, and we've got to figure out what these two items are before we subtract them. So the first thing I'm going to do is figure out what is 9 to the power of 2 and 2 to the power of 3. Well, 9 to the power of 2 is the same as 9 times 9, and 2 to the power of 3 is 2 times 2 times 2. Okay? So 9 to the power of 2, 9 times 9 is 81. Okay? And from that, I'm going to subtract 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8. Okay? I'm still working inside my parentheses. I just haven't finished yet. So if I have 81, take away 8. All right, I did my little subtraction off to the side, and that is 73. So inside those parentheses, I got all of that down to one number, 73. Now I've got to go back up, and I've got to bring down everything I haven't done yet. Okay. All right. So now I'm looking at what I've got next, which is my root, right? Roots and exponents are opposites. They're treated the same, just like multiplication and division. So when I go to the square root of 64, I go over to my multiplication table, I scan for that highlighted number 64, and I see that the square root of 64 is 8, because 8 times 8 is 64. That was an easy one, but I've got to rewrite everything I haven't used yet. Okay. And now I'm going to focus on my multiplication and division from the other side, okay? So I've got some multiplication and division here, right? We're going to talk about working left to right, okay? Because multiplication and division are equals. So I'm going to take my 36 divided by 3 first. And then when I'm done, I'm going to apply that little invisible multiplication that I had here and multiply my result by 4. So on my multiplication table, if I look up 36 divided by 3, I get 12. And then I have to go back to my multiplication table and find that my result, 12 times 4, is 48. So I'm going to put the result of this whole thing from left to right as 48. Okay. So now if I bring down everything I haven't done yet, 73 minus 8 plus the result of this, which was 48. Now I kind of have some left to right addition and subtraction that I can work on. I've got 73 minus 8, which I'm going to have to do on a sheet of scratch paper here. I'm going to save space on my screen. 73 minus 8 is 65. And now I have to add that to 48. I have enough space over here. I can do that. 65 plus 48. These are all positive, which makes it a little easier. 113.